Alright, this is the low impact development course. Introduction: Stormwater management using hydrological cycle approach, lead design goals and objective comparison of lead conventional practices, distributed microscale system. This course is adapted for the Unified Facility Criteria U.S. government, which is developed public domain, has limited distribution, is not copyrighted. Our introduction: Your low-impact development stormwater management strategy concerned with the maintaining restraint of the natural hydraulic functions with the achievement of the natural source protection objectives full environmental regulatory requirements. Low-impact development employs variety of natural built features, reducing rate of the runoff of the filter of the pollutants, facilitate the infiltration of water into the ground by reducing the water pollution, increasing the groundwater recharge. Low-impact development helps to improve the quality of receiving the surface of water, stabilizing flow rates of the nearby streams. Low-impact development incorporates sets overall sites driven design standard strategies as well as high localized, small-scale, decentralized source control techniques known as integrated management practices. Integrated management practices may be integrated with the building infrastructure landscape of the design rather than collecting runoff pipe with the canalized network control of flow downstream. Large stormwater management facility, low impact development takes the decentralized approach with the dispersing flows, manages runoff closer to where it originates because of low impact development, embraces a variety of useful techniques for control runoff design. It can be customized according to local regulatory and resource protection requirements as well as site constraints. New project and redevelopment projects, capital improvement of the projects can also be viewed as a candidate for implementation of low impact development. Show the conservation scale, preserve the natural native trees, vegetation, soil, maintains natural drainage pollutant patterns. Small scale controls mimics natural hydrology and processes. Customized site design ensures the site helps protect the entire watershed. Direct natural areas, ensure filterization, recharge streams, wetland aquifers, maintenance pollution, reduces pollution loads, increases efficiency, longevity, educates, involve the public. 1-2. Background of the use of low-impact development. The use of low-impact development pioneered with the 1990 with the Prince George County with the Maryland Department of Environmental Resources. Prince George and County population over 800,000. Land use of the county with a very diverse, ranging from sparsely populated natural with the agricultural area with the decently populated urban centers. Local impact development effort with the Prince George George County began with the development of use of the bioretention cell created by replacing existing soil with a high porous soil mixture of the grading of the area of the shell of the depression, replanting the areas with specially selected vegetation. Vegetation must also be totally temporary, saturated soil conditions as well. The pollutants contain local runoff when it rains. Bioretention area collects runoff and then filters out with the pollutants as the water passes down through the soil. The county's initial experience with the bioretention led with a full-scale effort with the incorporated low-impact development with the County Resource Protection Program. In 1998, the county produced the first municipal low-impact development manual, later expanded with the National Distributed Low-Impact Development Manual published in 2000. Feasible study prepared with the Low-Impact Development Center in 2002 provided guidance on how low-impact development can be used for the retrofit urban areas. Numerous municipalities include Portland, Oregon, and are incorporated low-impact development techniques in the urban resources protection programs. Although low-impact development concepts and techniques are new to many planners in the United States, many of these techniques have been successfully used in Europe or Asia for many years. Effectiveness of these projects over the managing runoff, reducing construction and maintenance costs, creating ancillary benefits for the community involvement has created significant interest in low-impact development. Impact development, changing and adapts these approaches and the techniques to the unique requirement of facilities on a wider scale. The discussion provided with the introduction guideline with the integrated with low impact development and planning with the design and facilities, regulatory resource protection programs, But useful engineering planners participate, maintenance personnel, regulatory compliance staff, community outreach staff who want a basic understanding of the technical administrative concepts associated with the design, construction, maintenance of low impact development features. It answers the following question: what is low impact development values? Does it have the facility owner? What is the basic design, construction, maintenance consideration? How can approach incorporate the facility operation work? Successful example: low impact development facilities and programs. Where can additional guidance be obtained? Low impact development site design strategies. The goal in low impact development site design is to reduce the hydrological impact of the development, incorporate techniques for the maintain and restore site hydraulic and hydrologic functions, optimizing low impact development site design, minimum runoff volume for the reserve of the existing flow path with minimized infrastructure requirements. By contrast, conventional site design runoff volume energy may be increased will result with a concentrated flow with required larger, more extensive stormwater infrastructure. Generally, site design strategies have for any project will address the arrangement of building, roads, parking areas, other features, and the conveyance of runoff across the site. Low impact development sites design strategies achieve all the basic objectives of the site design while minimizing the generation of runoff. Some example of low impact development site design strategies discussed as below include gradient enclosure sheet flow with length of flow path, maintain natural drainage divide to keep the flow paths dispersed, disconnecting previous areas such as paving the roofs and the drainage network while allowing runoff to convey over previous areas instead. Preserve natural vegetated areas, soil type with a slow runoff, filter out pollutants and facility infiltration, direct runoff into and across vegetated area to help filter runoff and encourage recharge. Provide small-scale distributed features devices that help meet with the regulatory requirement resource objectives. Treat pollutant loads which they are generated to prevent their regeneration. Low-impact development devices relevant with the size of the design with the once all appropriate design strategy for the consider of the proposal with the determinant with the stormwater management object with the abandonment of the stormwater management controls if required shall be located with the closed possible source of potential impact with the management with the water quality of the pavement of runoff. The example should utilize the devices should install at the edge of the pavement. These type of the controls are generally small scales to cover the site with the planning of the strategy with the have created small scale of the drainage area with the runoff volume of the committee design to address very specific management issue with the objective to consider the potential for every part of the landscape. When the selecting low impact development devices preferences should be given to those with the natural system process of the materials with the following list briefly defined low impact devices. Basic list integrated management practices. Here is a basic impact integrated management practices that are available. Bioretention, vegetated depression that can collect runoff, facilitate, infiltrate the ground into the ground. Dry wells, gravel, the stone-filled pits located to catch waterproof from the roof downspouts of the paved areas. Filter strips band dense vegetation planted immediately downstream of the runoff source designed to filter runoff entering the receiving structure of the water body. Grass swales, shallow channels lined with grass used to convey the store runoff. Infiltration trenches filled with a porous media such as bioremediation. Materials, sand aggregated to collect runoff, extra filtrate into the ground. Inlet pollution removal devices, small water systems that are installed below the ground edge of the paved area with the trap of the filter pollutants in runoff before edge of the storm drain. Permeable pavement, asphalt, concrete renders porous by aggregated structure. Permeable pavement is manufactured paving stones containing spaces where water can penetrate into the porous media placed underneath. Rain barrels and cisterns. The containing various sizes store with the runoff delivered with the building of downspouts. Rain barrels are generally smaller structures located above ground. Cisterns are larger, often buried underground, with maybe connected with the buildings, plumbing and integration system. Soil amendments, mineral and organic material addressed with the soil to increase the capacity of absorbing moisture and sustaining vegetation. Tree box filter, curbside containers placed below, covered with grate with the filter media, planted with the tree in the center. Vegetated buffers, no natural or man-made vegetated areas adjacent to water body, providing air corrosion control, filter capacity, and habitat. Vegetated roofs and permeable roof membranes overlaid with lightweight and planning mix of the high filterization rate, vegetated with the plants to tolerate of heat, drought, and periodic inundation.
Here's leftover pot pie.
I'll have some of that.
Are you sure?
I'll eat it.
I got some hamburger. I can make you some sloppy.
I'm gonna have some pot pie later.
Okay. Because I cleaned out the refrigerator with all the other junk.
Okay. Storm use the hydraulic cycle approach introduction development effect for the natural hydraulic cycle. For the hydraulic cycle consider the following process: convection, precipitation, runoff, storage, infiltration, evaporation, transpiration, subsurface flow. Hydrologic budget describe the amount of flow water flowing in and out of the area along with a different path with a discrete unit of the time, daily, monthly, annually, grading the construction of the building, laying over the pavement, and typically affect with the hydraulic budget for the decrease of the rate, infiltration, evaporation, transpiration, surface flow with the reducing ability of the natural source, increase the runoff in the natural conditions such as for the forest. It may take 25 to 50 millimeters of 1 to 2 inches of rainfall to generate runoff in the developed condition. Every small amount of rainfall can generate runoff because of the soil compaction connected impervious area with the result of the general increase of the volume and the velocity of the runoff. This in turn increases the amount of pollution that is carried into the receiving water, amplifies the generation of sediment, so that this will result in the bank erosion. Design inputs, both low-impact development and conventional stormwater management techniques attempt to control the rates of the runoff, except the method of hydraulic analysis. Particular site character of the conservative will depend on the nature of the project, land use, soil type, the slope of the vegetative cover, the size of the drain, age, or the average of the available storage of the typical site characteristics, the effect of the generation of the runoff, the roughness, slope of the geometry of stream channels, decay characteristics that affect the ability of the grade, the water of the well. A conventional approach of the stormwater management design typically include the hydrologic component of the precipitation, runoff, conveyancy, storage capacity, and their scope of low impact development design recognize the significance of the component's hydrological cycle as well. Here, how this otherwise components are actually taken into account will depend on the information available. The purpose of the design on low impact design objective. For example, that may be maintain low impact development design objective. For example, that may maintain a number of the groundwater recharge rate for the given site. Determine the appropriate number of the size and location infiltration devices can require extensive atmospheric data set, temperature, precipitation, calculate the evapotranspiration rate, along with a measure of soil hydraulic conductivity. Alright, the following sections describe that the low-impact development design can be in the precipitating, storage, infiltration, evaporation, transpiration data. Discuss include the brief description of each type of these data, compares these data with low-impact development and the conventional stormwater management perspectives. Alright, precipitation data. Precipitation data is also analyzed in terms of the frequency of the storm event, the different magnitude of the durations occur with a given location. Storm event design made into an account with the total annual depth of the volume generated with the storm season, specific frequency, duration, 2-year, 24-hour storm event with a hydraulic module, the precipitation data development with a synthetic design storm with a reflect with a pattern intensity of precipitation for project, location, region, and usual actual gauge data for the given storm event. With the level of the detail accuracy with the data depending on the requirements of the hydrologic model. For example, to develop the simple water balance for the on-site irrigation, only a few years or annual rainfalls total may be required. Some advanced urban hydraulic models, on the other hand, may require a collection of the rainfall data in 2 minutes intervals over the several years to determine the appropriate system design. Low-impact design precipitation analysis is an important approach to analyzing the effectiveness of low-impact design to consider the number of storm events which the design will provide enough storage of the infiltration capacity for the capture all of the precipitation on site with the useful may cause maintaining hydraulic integrity of the waterfall balance on a site. Better accomplish managing frequent smaller events rather than occasional large events. For example, the Washington D.C. the region are there approximately 80 storm events per year. The collective generated approximately 1,000 millimeters or 40% of precipitation. Approximately 75 of these storms events generate 13 millimeters or a half inch or less precipitation. Figure 2.1 illustrates the concept and shows the pie chart of regional national 2001 daily rainfall frequencies. This kind of analysis allows the designer to determine the overall storage of the infiltration capacity required with the control of the desired number of storm events in any given year. But the period of the analysis can be undertaken within terms of the precipitation depth associated with the discrete storm events in such 1 year, 24-hour storm. Conventional precipitation analysis, the conventional practice as well as made with the state local regulations, the other side with the engineer of the control of the specific events such as 2-year, 24-hour storm events within the Washington D.C. area. This would mean reducing the peak off of the runoff of the pre-development rates only of these events in which 3 inches percentage of rainfall events for the occur more or less frequently would be effectively controlled. Storage. Precipitation may temporarily detain when the site of depression help within the soil with the capacity for the depression exceed with the water released as the runoff of the captured further downstream. Water is not released as the runoff will be infiltrated into the soil, taken up by plants, evaporated back into the atmosphere. Natural land cover often presides. Depression stores small underulation for the topographically greater storage capacity is provided within ponds or lakes. Low impact development and storage concept. Low impact development employed with the site planning grading techniques for the direction maintain flow or runoff of the natural occurring storage area with such of the wetlands. Keep the storage area with the volume storage stable to help them maintain with existing hydrologic biological function of the storage area. Low impact designs may also include with the small retention components. Retention is defined with the volume of the runoff that never reach for the drainage area outlet. Retention can be provided with a variety of ways, not only with the support of the management of the runoff, but also as a supply water over the on-site use. For example, certain cisterns may be used to store and release water to peak flow control as well as store water in domestic purpose. Additional, some of the industrial buildings provide roof storage, release water. UV the cooling system is another example. Is a green wall within the building. The green wall is usually a modified temperature and improve the air quality having been stored on the roof flaw. Water flow across the vegetation, capturing runoff on small volumes, helps prevent erosion. Because of the runoff, it's likely to reach the damaged flow rate of the distribution storage component, but they also tend to result in more robust stormwater management system. Because of the failure of one component, but it will not cause the entire system to fail. Care must be taken with the bonding and storing with to make sure the adequate flow, infiltration, evaporation, and discharge unwanted carriers of disease such as mosquitoes are adequately controlled. Conventional storage concepts. Conventional stormwater strategies often include the stormwater in large, centralized at the end of the pipes facilities, storm design direct, conveying most of the runoff quickly as possible to these facilities, then discharge through an outlet structure with the two limited releases, 2-year, 24-hour to pre-development runoff rate. Conventional runoff management techniques can be dramatically reduce flow of the runoff from natural storage areas such as wetlands to provide the variety of the organism level of the moisture they need. Conventional approach then can have the negative impacts by removing the opportunity for the storage on-site rates. Groundwater recharge with the truth, in addition with a concentrated flow conveyed with large-scale facilities, accumulate with the pollutants, increase the erosive force of the water, which may be slowed down with the tree to maintain the natural energy of the chemical balance of the ecosystem, increase the temperature as the water is pulled, may also be detrimental to the ecological integrity of the receiving water. Infiltration. Water stored in the depression of the infiltrate with the soil with the different rates of depending on the soil type of the amount of the moisture already in the soil. Some of the water that infiltrates into the ground may then percolate further downward into the aquifer, travel horizontally, reappear when the surface flow, and then the stream portion of the water will held in the soil extracted by vegetation capacity of the soil will absorb the infiltrate water depending on the variety of the factors such as soil structure, pore space, particular size, classification percentage of the sand, silt, and clay, biological activity of the root and worms, water is faced by the soil system by various mechanisms of absorption, biochemical, biological reactions. Under natural conditions, significant portion of annual precipitation may infiltrate into the ground. As land develop, however, the main natural depression would otherwise collect with the water eliminated with the soil is compacted with the impervious area that have the form of the building the pavement. Consequently, level of infiltration takes the decrease when the site develop the additional runoff generated for the often result of the degradation water courses for the bank erosion, increased flooding, and alteration of the habitat character of the infiltration flow patterns. Processes are extremely important to maintain water balance in wetlands and the base flow in the stream channels. Low impact development infiltration concepts. Maintain natural infiltration rates and is important to the aspect of low impact development and design with accomplishing with the requirement with the accurate understanding of the existing soil of the ground comfort condition. For example, the clay soil with the pre-development site may have very little infiltration capacity. For the sandy soil with the compactor may have reduced capacity. This design should take care not to overload the hydraulic conductivity of the existing soil. Soil maps made themselves is not sufficient to determine the capacity of the soil to absorb and filter the water. Initial field testing is required to dispersing the flow, maintaining natural flow patterns, directing flow towards soil, which has high capacity for the infiltration to help maintain the groundwater level, the mending of the soil with the denting of the organic material, reducing compaction, aeration, maintaining leaf or duff layers in natural areas, reducing the compaction requirements for the non-loading bearing area, for the enhancing, maintaining infiltration rates and patterns, all of the soils, Natural areas are high capacity to filter and treat pollutants. Careful planning must be taken place to ensure potential pollutants such as the nitrates and oils and other urban runoff contaminants are adequately treated before entering any potential water supply. Infiltration areas should not be located near areas that have potential for hazardous waste spills and contamination. It is important to ensure that runoff is adequately filtered before and allowed to infiltrate, especially low aquifers are particularly shallow, and in the case of the water table is very high, often advisable to avoid infiltration altogether. Conventional infiltration concept. The conventional approach of the concentration of the infiltration capacity with a single end of the pipe management facilities such as a pond, infiltration potentials elsewhere on the site, with often this encountered and often analyzed for it effective the flow of the runoff into the facility. Conventional infiltration objective is to concentrate flow on the air with the utilize the infiltration capacity with the natural slope of the continuities such as gravel, natural groundwater flow with a pattern recharge are often not considered with the conventional approach, which may result in the elimination of critical volume of the flow with the distance of the area such as wetlands. Additionally, in many urban areas with high loads of fine sediment, centralized facility with the impact of the construction compaction very conserve, limiting infiltration capacity on the facility. Evapotranspiration. Evapotranspiration, loss of water from the ground by evaporating transpiration. Evaporation removes the return of the moisture to the atmosphere with the depression of the pond area of the other surface. The transpiration is the return of water to the atmosphere through plants. Moisture is absorbed then by the roots and released through the leaves. Rate of evapotranspiration is depending on the air temperature, humidity, wind speed, sunlight intensity, vegetation type, and soil condition. Low impact development in evapotransit concept. Low impact development is designed to use open air with vegetation to promote evapotranspiration. Large areas used with evaporation, such as ponds, should have the flow regime controlled. Mosquito breeding. Low impact development design should not pond water for more than 72 hours. It provided an opportunity for the mosquitoes to breathe and may keep the surface of the air within small and shallow. The water can quickly evaporate and pollutants volatilized through plant uptake with evaporation. Low impact development designs also employ the capacity of the vegetated areas to absorb, process, volatilize, treat non-point sources pollution as well as atmospheric pollution. Interception by leaf and significantly reduce requirement of storage. Infiltration maturity can intercept a significant number of small volume frequently occurring storms absorbing precipitation with the plant leaf the evaporating precipitation with the leaf source the additionally uptake of the soil moisture by plant helps to maintain the soil capacity to absorb rainfall. Conventional evaporation concept. Conventional stormwater approaches are based on peak flow through control over the short duration, usually 24 hours less. For these single event design, the evaporation process is often discounted and not considered. Alright, 3. Low impact development design goals and objectives. Introduction. Agencies are faced with the responsibility of managing and protecting the national resource of the often large parcel of lands reserved with many different functions. Usually can be intensive that can propose a variety of the stormwater channels. For example, the industrial facility with the supermarket may generate the stormwater pollutants after the downstream hydrology. No single management practice that can be universally applied to all drainage areas. Figure 3.1 illustrates move effectiveness variedness of best management practices. Variety of the pollutant. The table below illustrates the complexity of storm management. There are no single best management practices technique to be used effectively to address all of the additional watershed issues. This shows particle size, grading, treatment pressures, hydraulic loading. Alright, regulatory and natural resource design issue. Many regulatory compliant flood control peak rate design schemes of the construction are designed that achieve only one objective of the pre-development control for 2 years, 24-hour storm event. The regulation often the fail to consider overall nature of the resource management, hydraulic objective of the stewardship, the responsibility of the facility with the budget constraints for the often limited construction funding. It is not necessary for the conveyance of the flood control requirement. The limited framework may create with a situation where regulatory requirements are met. Design result of the degradation of natural resource low impact development principles. Use the hydrology with the integrating framework of the design protect the overall ecology of the watershed. Low impact development allows facilities to meet the regulatory requirement for the flood control, storing infiltration of sufficient volume while sufficiently filtering target pollutants through natural and man-made systems. Fundamental site planning concept. The goal of low impact development site planning is to allow for the full development function intended with the activity while maintaining site essential natural existing hydraulic function. Low impact development site design processes subsequently iterative embraces the following 5 concepts. Hydrology, integrating framework for the design, distribute and control through micromanagement. Stormwater is controlled at the stores. Utilize the non-structural system where possible. Create multifunctional landscape buildings and infrastructures. Hydrology is an integrating framework of the design. Low impact development designs have the goal of mimicking the natural site of the drainage process function. The techniques are used to modify the hydraulic processes such as infiltration storage to meet the specific water quality, water quantity, and natural resource objective. The low impact development design creates effective drainage processes, stream water on site. The storm management system will come closest to mimicking natural flow patterns when storage and infiltration components are distributed across the site. Distributed control of the through micromanagement. In order to emulate nature processes and operative the view of the site with the interconnected small-scale design control, so the structures creates opportunity with the redundancy within treatment and with the control of the development of the treatment train for water quality control and the opportunity to strategically locate the low-impact development components. Alright, stormwater is controlled by the source, controlling the treating of the runoff that being generated, reduce the eliminate the risk associated with the transporting pollutants further downstream through pipes and channels. Management of the storm at the source is especially valuable if remediation is required in such a case that if the accidental spill pollutants because of the problem can be easily isolated with the treatment system is adjusted. Incorporate non-structural system. Low impact development design recognize the potential for natural system that intercept the filter pollutants. PIOTO remediation techniques have taken advantage of the biological chemical process of the plant soil complex have shown tremendous potential in the stormwater management. These natural systems are easy to design, construct, and maintain, even though the natural occurring filtering of the treatment process may be quite complex and multidimensional. Benefits of using three small-scale simplified systems such as soil amendments, landscape, and revegetation include the reducing need to cost largely scalable construction projects such as underground concrete vaults as proprietary filters. Figure 3.2 illustrate the range of the biological chemical processes that have been documented to occur within the bioretention cell. The bioretention cell is the landscape area construction of specialized soil plants that can be effectively absorbed and treat urban air runoff. Alright, and then it shows your air, particulates, rainfall, biological exploration, defiltration, absorption, evaporative transit, NHS, nitrogen, hydrogen, sandy soil medium, and the NO2, NO3, and de-energized nitrogen fixation, NO2, ammonification, drain, infiltration, recharge. Alright, 335. Utilize multifunctional landscape building infrastructure. There are a wide variety of low-impact development practices available. The primary criteria for the listing of low-impact development practice for the design with the component that contribute to satisfying with the design regulatory objectives. Some features are often multifunctional, satisfy multi-objective with the development of vegetated roofs. A good example of vegetated roof can reduce the effect of the atmospheric pollution, reduce the runoff of the volume, the frequency, reduce the energy cost, greater the attractive the environment that have the reduced replacement, and maintenance longer life cycle cover. They are maintain vegetated roofs that can develop and include pre-made grill cells or whole systems. Low impact development management and design strategies. Low impact development design is an iterative process required through understanding of the management objectives, detailed understanding of physical and natural resources on the site with a conceptual site design that can be refined to achieve the goal of the hydrologically functional landscape and long-term maintenance plan. Low impact development site planning components. The section presented the aims of low impact development site planning line of existing site development requirements. Describe low impact development site and design can be the best approach to manage runoff. Hydraulic objective. The purpose of low impact development site planning is to significantly maintain pre-development runoff at a low rate, ideally with where site conditions allow. That will be achieved in a way that replicates the site with redevelopment hydrological function site that are characterized before the development by pure soil, substantial vegetative ground cover that ungraded and topographically necessarily perform several important hydraulic functions. Facilitate infiltration, evapotranspiration, retention, detention of runoff, limit runoff flow rates, cover the ground surface runoff roughness, help control water quality through surface to subsurface filtering with pollutants and sediments. On a developed site where these hydrological functions can continue to be provided with the preservation of natural features of the construction and variety of the man-made features taken together, utilization of features of the compromised distributed source control of the strategy of the design is not only to meet the regulatory requirements but also to provide supernatural resource protection, maintaining area with a high soil parts or porosity, vegetation, ground cover, and shale pounding will meet the help of the following objectives: flood control, facilitating infiltration of the running of the decreasing overland of flow rates to reduce the risk of flooding in the preceding waters to meet the design objectives. Regulatory requirements completely supplemental controls may still be required. Volume control, overall volume runoff that leaves the site kept as possible the pre-development levels. Peak control, peak runoff rate that does not increase the pre-development level. The entire runoff of the hydrograph eliminates the pre-development hydrograph. Filter treatment of pollutants runoff the directed across the vegetated area through the porous media to provide significant reduction in the concentration of sediment pollutants in the water, groundwater recharge, and for expedited to enhance the groundwater recharge rates to help sustain base flow in nearby streams. Alright, low impact development design approach. Low impact development approach for the site design seeks to maintain and restore the hydrological impact of the site development using the combination of the runoff management strategy, site design technique with distributed source controls, integrated management practice of the low impact development design required for the site plan and drive for the overall natural resource complying with the issue of the watershed of the long-term success of the approach that requires to understand the maintenance requirements for the life cycle of effectiveness of the low impact development practice for the development of the appropriate maintenance and the pollution prevention planning for the facility. While the influence of each of the components of the design process varies for the site, the site of the general process has been developed to ensure that all the components are considered. Although the preference of low impact development design and reduce the hydrological impact on the site of the retained natural effect of the hydrological features is recognized that the significant impacts may occur because of the nature of the certain activities when the compensating features are required. Low impact development emphasize the use of the integrated site feature of the control runoff as close as possible to the source rather than transporting pollutants and attempting to mitigate loss of the functions elsewhere. Table 3.3 illustrates the general flow of the design process. Conserve natural areas, minimize development impacts, maintain watershed timing, provide integrated management practices, manage pollution prevention. This approach is often an iterative process that requires several attempts to balance all of the way to design components with the most economical, environmental, but effective way to describe below the individual design components. Conservation natural area. Low impact development, stormwater management strategy that address the overall regulatory resource protection goal of the site with the watershed context. Both cover development typically occur with the incremental. This approach will allow the adjustment of the modification site design strategy. The technique for the reflect the dynamic resource protection regulatory issue of the communities and bases often have extended the watershed management and natural resource for the conservation goals. Master plans identify the site and sensitive environmental areas, preservation areas such as the wetlands, mature woods, habitats. Low impact development site design should be addressed any of the potential impacts of the areas, encourage conservation of the area within the site. The example of conservations are included: preserving the forest corridor that connects the existing stream valley, maintaining flow volume discharge rate to offset wetlands, incorporating buffers around sensitive habitat areas. Minimize the development impact. While the portion of the site selected for the placement of the roads and building other development activity, minimal disturbance techniques, site fingerprinting can be used to avoid soil compaction, retain the mature tree, then limit the environmental impact of the staging area. The example of the minimal disturbance techniques include eliminating flagging, small site with the disturbance area if possible, minimize size construction impacts off-site with easement properly acquisition, minimize the size of material storage area during and after construction, maintain flow patterns. Alright, control watershed timing and runoff pattern with maintaining the site with the natural runoff control area with restricting building over the site with the more pervious soil will help keep the infiltration capacity on the site with the close of the pre-development level to maintain the watershed timing on the site, but it also is important with the cumulative effects of the decreased post-development watershed type with the concentration of several sites on have significant impact on the downstream habitat. Also, it is desirable to maintain natural vegetation, steeply sloped areas, and to retain the natural drainage of divides. This encourages dispersed flow pattern, with the consequently help reduce the development of the channel with the lead with erosion flood problems. Adequate drainage from the building, walkways, roads must be provided with traditional design with a drainage system that was effectively increased the rate with the runoff moved into the receive of the warm water draining storm events. In turn, this produces a higher volume of runoff, higher peak ratio flow, and early runoff event would occur under less development conditions. Opportunity for the groundwater to recharge is limited because the infiltration into swell with grassy air is connected not effectively occur if the runoff passes through quickly. The overall grading objective of the low-impact development is to provide a surface landform that will distribute the flow with a shallow, slow-moving pattern towards area where infiltration capacity is highest. The low-impact example of low-impact development techniques control rates to runoff and watershed timing include use of flat rather than steeper grades to provide adequate range for buildings and traffic to maintain. Reduce the height of slopes to prevent runoff with gaining speed as it moves downhill. Where flow begins to accumulate, increase the length of the flow path, diverting and redirect flow, preferably the vegetated areas. Minimize use of curb and gutter system, pipe drain systems in favor of the grass walls. Minimize and improve this area. Use the pavement to disconnect the impervious area with the directing runoff of the buildings and pavement onto lawns or other vegetated areas, keeping flow over the velocity with a level within, not causing erosion. Preserve naturally vegetated areas existing topographically in place where these help slow runoff and encourage infiltration. Use weirs and check dams and swales. Our use of the integrated management practices. Once all of the design and strategy techniques have been implemented, integrated management practice for the selective achieve with the slight water quality, the quantity of the objective with the integrated management practice for the distributed multifunctional small scale control selected based on their ability to achieve the site design, water quality, quantity, objective, and cost effective manner. Integrated management practices are not one size fits all approach. For example, the use of the amended soil filter of stream runoff may be inappropriate for the Royal Road section with a higher traffic than inappropriate for the next to the parking area, then be subject to the compaction for the overflow packing with a parking with a vehicle movement. Pollution prevention. The goal of the pollution prevention is to reuse, recycle the variety of the pollutants before they become an environmental problem. Final step of the low impact design approaches to low impact development design approaches to incorporate programs to keep pollution out of runoff first practice. Consequently, to increase the longevity and integrated management practices, reduction fertilizer, pesticides, herbicides, due to the implementation of regular street sweeping areas, common pollution prevention activities. 3.5 Design Guidance and Standards. Method of determining effectiveness. Stormwater projects are typically designed with a particular objective in mind, such as flood control, water quality improvement. Such projects typically require designer to evaluate the effectiveness of the proposed treatment of the meeting of the stated objective number of the hydrological modules. Having developed a model surface runoff the drain, given the drainage area, because of the conventional methods of eliminate concern with the computing flow rates, the flow of hydrographs, or point of interest. The approach for hydrological analysis must be made modified in case where not all runoff of the given site with converges into a single point. The typical watershed model will take into account with the general land cover, the stream chemical, stream channel characteristics account, low impact development, the feature of the runoff management devices, refine the analysis may be desirable. Variety of tools are free and available from public agencies. Your Natural Resource Conservation Service, Natural Resource Conservation Service of the NRCS, formerly with the Soil Conservation Service, has developing a runoff model for the decade with the Natural Resource Conservation Service models TR20 and TR55 account variation land cover, velocity water movement across the watershed on particular interest, the determination of the drainage area of the curve of the number, and the time of the concentration value of the CN curve number reflects the degree of the land surface condition of the generator with the runoff, of which the value of TC, or time of the concentration, indicates how quickly the runoff will converge at a particular point downstream. The TR20 and TR55 are popular watershed build modeling, but are generally not recommended with predicting runoff from small storms. Federal Highway Administration has developed a variety of software packages preliminary concern with the channel, the pipe, of the hydraulics. These features programs most usefully in the area of the detailed analysis of flow behavior based on the predetermined flow rates is required. Hydrological Engineer Center of the U.S. Army Corps Engineer actively maintains a suite of tools modeling surface water of the hydrology and hydraulics. The EPA mans stormwater management model that performs simulation of the both water quantity and quality of the urban runoff events. In late 2002, EPA extensively revised the stormwater management model to include more detailed analysis of small-scale stormwater management devices. Small stormwater management model algorithm is able to implicit stimulate storage and therefore particularly appropriate stimulating discrete low-impact development systems, setting a reasonable estimate of the storage parameters in the eve of the stormwater management model is critical for the important creative adaptation of the stormwater management model may be necessary because the model depends on the model runoff of the impervious source into the previous one. Are your Prince George County, Maryland, Prince George County Department of Environmental Resources for the Program and Planning Division working on the Tetra Tech Incorporated have developed the best management practice for the evaluation module to assist the assessing effective and low impact development technology of the module. Use the simplified process based on an algorithm to simulate the best management practices control model flow for the water quality of the time series generated through the runoff of such hydrological simulation programs as the Fort Rain HSPF. These simple algorithms include weir and orifice control structure, the normal swale, character of the flow, pollutant, transportation flow, routing, networking, infiltration, saturation, evapotranspiration, general loss, decay, representation for pollutants. It offers you the flexibility of the design retention style with an open channel of best management practice, defined flow, running through best management practice network, and stimulate integrated management practices such as reduced continuous impervious surfaces through flow networking, compare best management practice control against defined benchmarks such as stimulated pre-development conditions to cover the underlying algorithm based on the physical process of the basic best management practice effectiveness can be evaluated estimated over the wide range of storm conditions. Best management practices designs and flow rate configuration such tools provide quantitative medium for the assessing and designing of the total TMDL allocation scenarios evaluating effectiveness of the proposed management approach. 5 basic design aspects which will develop the methodology of the module are 1. Incorporating the input of runoff data. 2. Design representation of site plan. 3. Configuration best management practice various sides of the function. 4. Schematic representation flow routing through the network of best management practices. And 5. Evaluating impact of site design on the best management practice of the module interfaces, platform interactive linkage between each of the 5 design features module. Our commercial sources. In addition to the free available module, there are a variety of commercial models of the market. Information about these other tools can be found on the internet. Monitoring strategies. Variety techniques are available on the monitoring effective and the low impact development feature of the managing water quality and quantity. Water quantity monitoring effective low impact development control running off the volume of the peak of the flow rates can be monitored either with an individual feature on site at some selected point downstream where flow paths converge and a measure device can be installed. Small scale both manual and automatic sampling methods can be used to calculate flow rates upstream downstream of low impact development. Installation based on depth measuring using a weir over rate of flow measured using conveyancing device. Alright, your large scale. On large scale, where low impact development features are you with the retrofit of the developed area with the effectiveness of the retrofit can be assessed by comparing low impact development and post low impact development flow rate downstream. Using these data is somewhat straightforward hydraulic calculation characterization hydrograph can be developed to evaluate certain responses to storm events resulting in implementation of low impact development treatments. Data and stream gauges should indicate the runoff of smaller storms has decreased after low impact development implementation. Also, more low impact development features use the stormwater retrofits on the site with a decrease in runoff more than significant. Water quantity monitoring parameters. Effectiveness of the runoff management feature evaluated through the flow through the feature quality of the receiving waters of both nationwide urban runoff program or NERP has been identified with the following standard pollution characterization urban runoff. And table 3-4 shows standard pollutants urban runoff. Alright, biological monitoring. Pollutants stormwater runoff is directly affect the biological intake of the receiving water, affecting with the water quality control, thereby evaluated assessing the biological health of the receiving water vicinity with the stormwater outflow. The EPA has developed a rapid bioassessment protocol that can be used to characterize the existence of the severity impairments of the stream and help identify the sources and cause of the impairment. Monitoring the program or phase developed in monitoring program. 1. Determine the objective and scope of the monitoring program. 2. The developed monitoring program with view of the objective. 3. Implement the monitoring plan. Implementing the monitoring plan. And 4. Evaluating report of the results. Monitoring programs are shaped by the site of the character of the goals of the project, regulatory requirements, and availability of the funds. Variability. High variability of stormwater flows and pollutant concentrations within any location makes it difficult to obtain. Use of monitoring result of typical facilities must collect a large number of the sample to adequate characterize how the device and function under the natural condition. Monitoring approach either any of the given site depending on the regulatory requirement of the pollutants, of the concern of the physical character of the runoff management features, availability of the funds and personnel of the planning, sampling, analysis. State and local program conformance. Water quality monitoring programs should be undertaken with the conformance of state within local protocols. Detailed guidance monitoring manual of the water quality data collection management interpretation is available to the Environmental Protection Agency, the Department of Transportation. Guidelines were all primarily concerned with meeting the National Storm Best Management Practice data requirements and easily adapted for using the variety of monitoring activities. Sample location effective monitoring effort with a decentralized runoff management requires judicially selecting the sample location as well as sampling techniques. The challenge is often complete with the monitoring effort effectively under budget constraints. If the site design includes many of the low-impact development features, sampling only a few many of the provide reasonable basis to estimate the effectiveness of the full suite of the features. Sampling protocols. Monitoring the protocols vary depending on the expected the chemical composition, runoff, the pollutant, of the concern of the desirability of monitoring of the effectiveness of the device for the given location, importance for the assessing water quality at points downstream. Sampling data is collected over time. The trend of the water quality becoming apparent with adjustment of the monitoring plan may be appropriate to ensure that across the site samples are not taken any more or less, frequently necessary to ensure that the desired level of water quality is maintained. Alright, 4. Comparison of low-impact development conventional practices. Let me check the time right here. Alright, comparison of low-impact development conventional practice. The introduction of conventional stormwater management practice with the focus of the provide efficient site drainage system to rapidly convey the runoff away with the storage for the buildings off pavement and attach away to the peak runoff running off the rate of the large stormwater management facility downstream. Contrast low-impact development provides runoff management as far as upstream as possible where it originates, and if necessary, also multiple points along each of the flow path. Low-impact development conventional practice can be further compared in a variety of ways. Compliance with water resource objectives. Conventional stormwater management primarily concerned with the actuation of the peak runoff rate with the development of the site. Principal goal of low-impact development is to ensure maximum protection of the ecological integrity of the receiving waters by maintaining watershed hydrological regime. Water quality control. Prevent drainage path effectiveness. Reduce peak runoff rate, but do not reduce the runoff volume. Instead of the conventional drainage practice, but increase the runoff volume, but not mitigate the effect of the increase impervious area. Low impact development, the feature of the facilitate infiltration comparison and help to reduce runoff of only directly. Runoff volume reductions used in the low impact development feature can be significant. You want an infiltration increase over sufficiently large area. Conventional drainage reduce the amount of the subsurface water available to base flow in nearby with stream. Low impact development feature for the enhanced infiltration can have the beneficial effect of helping to maintain those base flow of the other low impact development features that also use the strategic use of the stormwater on site, while conventional drainage is designed focuses on moving the water rapidly off site. With the conventional stormwater management facility has a limited ability to manage water quality because of the limited to remove the settlement and pollutants. Low impact development approach by the comparison takes advantage of the variety of mechanisms to filter weather either overland or via the infiltration to the subsurface. Our construction cost of the low-impact development vary depending on the character of the pre-development site, each of the density of the development, the particular low-impact development features select for the site of the design, for example, the cost of the bioretention area, with the will flow, with the depth of the forest backfill, with the degree of the underdrain that are utilized, case study of the commercial townhouse, the detached home and residential area of the Prince George counties, Maryland have the demonstrated with the low impact development site design costs are comparable with the variable of the conventional approach. The cost area of the non-simple to generalize the scale of the project availability with the material scale of the training of the staff. All the factors integrated management practices involved in landscape areas are often simple to maintain because of the work that will often be performed by landscaping crew that were resident of the high-end hard structures such as permeable paving system where the under drains may require more specialized maintenance. Alright, operation and maintenance. Regular inspection for the conventional stormwater management facilities are required to ensure that the storm volume have not reduced the sediment outlets with the not clogged with the debris with the structural feature for the maintaining their integrity for the site with the design with the low impact development and approach for runoff management of features will tend to be higher with the number of several types of feature of the bioretention area the need to maintain with the proper RDP owner. Mainly for the low impact development the feature of the straightforward they can easily perform in part of the regular landscaping and other low impact development features typically employed with long public streets such as the tree filters required with the more specialized maintenance maintenance to ensure the filter media are not clogged with toxic materials such as heavy metals due to the accumulate through the level at which they become a health hazard. Retrofit potential. Retrofitting an already developed area with a conventional storm water management system requires a considerable amount of the space. It's likely to involve the extent of the size of the site, disturbance, local and low impact development, microscale systems listed as previously a chapter from the previous chapter requires less site disturbance for the other in each installment. Low impact development retrofits may be too much. Even if the conventional retrofits on site with the extensive development has already occurred. Locating site with installing small devices is far easier than finding a large site. For stormwater management facility, low impact development retrofits can be customized to pollute inlet loads, allow more complete control over the pollutant removal. Alright, 5. Distributed microscale systems. Introduction. In addition with large land surface strategies, local impact development practices include incorporating small landscape features of the manufactured devices into the site with the management of the runoff generated, reduce the need with the management further. Downstream, small distributed systems can perform some of the important runoff management functions. Increase rates of infiltration, slow down runoff, reducing flow rates within the site with increasing time for the infiltration. Add retention of the amount of the water stored over the surface over the duration of the storm event. Add attention which causes the water to be restrained temporarily before it moves further downstream. Improve water quality for the filtering pollutants through the media. Representation of low impact development practice. Low impact development use the design component that can be selected, customized specifically to stormwater management object with the less selectively use the customization of the components that involve a variety of standards, specification for the construction maintenance described below with a collection of the low impact development practice with use design with construction maintenance with characteristics of the distributed microscale systems can include but are not limited to soil amendments, bioretention, dry wells, filter strips, vegetated buffers, grass swales. Infiltration trenches, inlet pollution removal devices, rain barrels, cisterns, tree box filters, vegetated roofs, and permeable pavers. Table 5.1 presents runoff management functions provided in these features. Show the features, the effects of slow runoff, the infiltration, the retention, the detention, and water quality control. Nutrition and processing. Surface water runoff of the urban area include the significant quantity of the chemical nutrients, particularly with the nitrogen and phosphorus. These nutrients reach the local water bodies that contribute to the eutrophication of the natural occurring process. Nutrients accumulate in the body of the water over time. The term is often used to signify acceleration of the process by human activity. Several low-impact development components described in the UFC Chapter 8, but the filter of the nutrients varies to the degree of the effectiveness depending on the design. Low-impact development approach for the utilized vegetation not only filter nitrogen, phosphorus out of water into the soil, but also make these nutrients available to the plants of the plant tissue. Our treatment train approach of the water quality. Follow with a typical flow path at the beginning of the winter or the runoff of the generator within purpose area of the runoff water quality can be implemented in the following steps. Minimization. Design the site with a treat with the pollutants affected with a small quantity rather than a larger quantity of the runoff is accumulated before treatment. Natural filterization. Use physical, chemical, biological properties of vegetation soil to filter pollutants. Construct filterization. Physical, chemical, biological properties to distributed microscale system with the filter pollutants. Evaporation. Store, evaporate waters and shallow depressions so the particles can be removed. Pollutant prevention. Incorporate management practices such as restricted fertilizer. Use the diligent street sweeping to reduce the pollutant loads. Note that when the first 4 steps of the site feature of the final step pretends the post-construction maintenance. Figure 5 shows the typical treatment of the train process for phosphorus removal. Alright, 5.2.3 energy processing. Low impact development feature for the incorporated vegetation can help with the moderate with the high ambient temperature of the even on small scale vegetation will have the low cooling effect. Vegetation can be selected with a place and improve the chaining or to provide a buffer against winds. Use the vegetated roof that can result in significant energy saving operation of buildings' air conditioning system. Multifunctional infrastructure buildings. Some of the low-impact development features can simultaneously improve the variety of the hydrologic function by retention area. For example, it can filter runoff with the quality control, detain it, and infiltrate with the stormwater into the ground. Similarly, vegetated roofs on buildings reduce runoff and reduce pollution on both water and air, moderating with the internal building temperature. Ancillary benefits of the discussion describe low impact development primarily in the terms of hydrological impact, low impact development, runoff management strategy for the community. Also contributed to the atheistically pleasing landscape, increasing value of the property. While these strategies are employed with a variety of completed projects, micro-scale runoff management features have provided architectural interest of various forms, such as employing berms in otherwise open spaces, rainwater channel that allow along pedestrian street foundation fed intermittent stormwater bioretention areas that are attractively subdivided large parking lots. The visibility of these features also provide opportunity for citizens, property owners to become more aware of the importance of stormwater in urban development. Urban environment. Alright, and then it goes on to the final exam, and that was a introduction to the low impact development course. Testing.